Hello guys, good evening. I hope you're doing well. So let's start today's session. So today's topic is the deep learning computer vision, right? So in the deep learning, we basically deal with the two fields. One is NLP, which is natural language processing, where we deal with the text and voices, right? Second is the computer vision. In the computer vision, we deal with the images and the videos. So let's talk about the image first, right? So we have the basically three kinds of image. One is a black and white image, looks like this, right? Where every pixel will be either black or white. Pixel is the smallest unit of image, just like a cells in our body. Then we have the grayscale image. This is called the grayscale image, right? Where we have all the pixels in the range of 0 to 255, between black to white, all the shades of gray, right? Third, we have the colored image. This is the colored image. Right. So this is made up of red, blue, and green. Now, in the gray image and the black and white image, we have the something called number of channel. Number of channel will be equal to 1 in the gray and the monochrome images. But in the colored image, this number will be 3. For the colored image, this number will be 3. Okay. Let's see. So let's take an example here. If I have the image, if you can try to identify the face here, it's quite blurred because of the very low quality image. And this I kept for a reason. Now, for example, here we have all the pixels, right? You can count it, all the pixels. So now if I start counting all the pixel from here to here, it will be 12 pixel. It is 12 pixel in this case. And if I count from here to here, in this case, it is 16 pixel. So the size of image will be 12 by 16 by 1. What is 1 here? This is nothing but number of channel. In case of colored image, this number will be 3. Okay. Now, if you see all the pixels are is nothing but a number, right? Nothing but a number. And it's all between 0 to 255. If the pixel is close to 0, it will be black. If the pixel is close to 255, it will be white. So now if you see carefully, right? So these are the pixels. The value is 0. This is nothing but a black. Now if I see, right, this is very close to 255, it's a white pixel. Now ultimately what we did, from this image, I have got a matrix, right, represented by a number. So one more very important concept, my Python cannot handle anything but the numbers. Okay. So beats text, beats image, I have to convert this to the numbers, right? So now let's assume that we have converted this as a number. Now I have this grayscale image, and all the numbers are between 0 to 1 fraction value because we have scaled it. So from 0 to 255, now all the pixels are between 0 to 1. Okay. Now coming to the colored images, we have 3 channels, red, blue, and green, and everything is just like the black and white channel except the number of channels. So here in this case, we will have 3. In the black and white and the grayscale, we will have 1 channel. Any question, guys? Please let me know if you have any question, any doubt, confusion. Okay, no questions. Very good. Now, let's talk a case, image classification. We all know that what is classification, right? In this case, today we are going to deal with the how to classify an image. We have classified, right, with the structured data. Let's say, for example, telecom churn, banking fraud, right? Am I going to lose or win? Who will win the presidential race, right? So something like that, right? Now we are going to deal with the image classification. So first thing that I need to convert this image to a number, and then we need to do certain operations. We call it the pre-processing. So just in case of machine learning, we have done like missing value treatment, right? Outlier treatment. We have checked if the data was correct, data type was correct. Similarly, we are going to do a lot of operations, right? But it's very easy actually. So assuming that I have an image of size 5 by 5. Why 5 by 5? I have taken it for a simplicity so that I can explain it. So this is my image. Then we'll have a filter. This is my filter. Filter is usually square. Image is also, it can be square or it can be rectangle as well. So the size of filter is 2 by 2. Okay. This I represent by value small n. This is by small f. Now I perform a convolution operation. But why do we do that? So if I perform a convolution operation on image by using filter, I can extract the feature, right? For example, edges, right? Sharpness, we can find out the shapes and so on. So image and filter, then ultimately the output will be a feature map. You see a lot of numbers here, right? So these numbers are random numbers, right? I put between 0 to 0, 1, 2, 3, 4 so that it's easy to explain. Correct. Now, so this is my input. This is also my input and this is my output. How I'm getting this? So let's check it. So now what will I do? Because the size is 2 by 2, I'll take a box of size 2 by 2 here as well, right? 2 by 2. Now, the first value of this box and first value of this box, I'm going to multiply. So 3 multiplied by 2 and then sum, then comes the second value. 2 multiplied by 2. Then I am going to discuss about 2 and minus 2. I'm going to multiply these two. And then 3 and minus 2, this one. 3 and minus 2. Now we will calculate this. So this will be 6 plus 4 minus 4 and minus 6. Ultimately it will be 0. So that is what we have got the 0 output. Now, what next? So we have something called stride or we call it a sliding window. So I am going to move this. I have moved just by 1, right? So in this case, the sliding window is 1. If I move it by 2, then the sliding will be 2. Okay. So let's discuss with the slide window 1 or we call it a stride. So after calculating the first one, let's say I got the value 0. Then I'll move it to here. Again, we'll perform the operation similarly. My filter is fixed. I will get the value minus 4. Then again, I'm going to move it. I'll get 0. And then 4. And then I'll come here. This way. Again, I'll move from left to right. Okay. So we have something called a formula, right? Stride. Let's say the stride value is S. So N minus F divided by S plus 1. This will be the size of your feature map. So in this